Hello, and welcome to our instructional series on PAX-it Image Analysis and Metrology. In this video, we will cover the basic steps to create a saved test using the PAX-it CD module, a tool commonly used in the semiconductor photolithography lab for maintaining process control through a wafer lot. First, with an image open on the PAX-it desktop ready for measurement, we navigate to the Analysis tab and then to the Critical Dimensions wizard. Clicking the Critical Dimensions button launches the CD module wizard. From here, a saved test may be rerun, edited, or a new test may be created. An unlimited number of saved tests may be stored for reuse as is often required. To create a new test, make sure New Analysis is highlighted at the top and click Next. A background subtraction may be applied to remove image artifacts that may be showing due to dust or other optical anomalies, as is sometimes the case with older instruments. If applicable, click the Select File button and choose a captured photo of your microscope's background. PAX-it will subtract the background from the image being analyzed, ensuring that object detection and measurement is not skewed by noise from the background. In the Select Pass panel, we define a name and orientation for the structure we will analyze. You can type a custom name into the name field or simply use the default name, in this case CD1. Clicking on the lookup table just below, we select the orientation of the structure to be measured. In this example, the structure is horizontal, so we will select Lines Run Horizontal. If we were to have a vertical feature, we would select Lines Run Vertical, and a curved or an angular structure, we would use Any Angle Single Slice. Creating additional passes is useful if we wish to measure multiple features on a single image. We'll click Add here to add this single pass for our purposes, and then we'll click Next to begin to define the settings. So now we're in the Region of Interest panel. The rectangle option appears highlighted automatically, and we'll simply click and drag to identify an appropriate region of interest, remaining mindful to have sufficient background selected for a proper optical profile. Now we click Next, and the optical profile panel now displays. Here, the process engineer defines what to measure on the structure by creating a saved test that corresponds to material types and processes being used in the wafer's production. Note the optical profile, the threshold bar, and the readout of the line width in the upper right corner shows us the target dimension that we're attempting to measure here. To define additional settings, we'll click on the Graph Settings button. With this displayed, we can set up our preferred color scheme as well as configure the measurement test to address this current application. We can address the graph settings. We can select the curve fit that addresses whether we have a nice sharp straight line or a wavy fuzzy line. Different algorithms allow us to address different conditions that we might have in the fab. The edge detection settings are critical, of course, and some processes will have both inside edges and outside edges, so we need to teach the system where we want it to measure. We have a custom edge routine that we can configure. In this case, I've got a custom routine for pitch measurements, leading edge to leading edge of structures in a field of view. And then, of course, we can select the number of measurement samples or slices throughout that region of interest. So I can have 100 slices if I want to get a nice average of this structure. I'll leave it here at 5 for our training purposes. Once this has been configured to our preference, we'll click OK. And then we'll click on Next to reach the final panel of the CD module wizard. This option allows us the ability to go back to the beginning of the setup to create a second and third pass if desired. If we want to again measure other structures within the same field of view. The detection settings option is grayed out here as it's not used for the CD module. The Save Settings button allows us to save this as a current test. So by selecting this option, we can add a title for saving. We can add a description if there's some particular description that might help operators select this for particular tests. We can note that here. And then we can note reload options. What options or what functions do I want the operator to manually address? For instance, if we're going to use this CD test for various structures in different locations on the wafer, I might want the operator to be able to move the region of interest to the appropriate location and then measure in that location. So we might want to select that. Once we've configured our saved test, we'll click on OK. I also will note that you have the option to select the PAX-it measurement totals opening automatically and to generate a measurement data report automatically from a group of saved reports that we have in PAX-it. They appear in a list and they're easily selected here. They can be custom modified by the users as required for corporate look and feel, of course. These are included in every PAX-it installation and are available for use. Once this is configured, we'll click the Finish button. It will launch the PAX-it Measurement Totals window, and we'll see our measurement data. Here, the green indicates that these measurements are in specification, based on specifications that were installed originally. We can review the actual optical profiles of each of these individual slices one at a time. If there's an error or something unusual, an adjustment can actually be made on this screen that will affect the measurement on the image. And then we can graph the measurement data directly from PAX-it so that we don't have to configure it, say, in an Excel report. Finally, from here, we can do a transfer to Excel report with a single button click and create a brand new Excel spreadsheet with multiple tabs. Moves all the measurement data into the report. All the optical profiles are shared in the report. The image with the measurement tags and the PAX-it ID tag, which are the database yields associated with this image, and the camera metadata, which stamps the date and time, the image resolution size, and the calibration values. All of this data is included in the reporting environment. Thank you for your interest and time. Hope that you found this instructional video to be helpful. If you require further assistance, please be sure to contact MIS either through our website at www.paxit.com or email us directly at sales@paxit.com. Thank you and have a good day.